Hi and welcome to the video training of Elixir. In today's video training we will be learning about protocols. Protocols are a mechanism to achieve polymorphism in Elixir when you want behavior to vary depending on the data type. We are already familiar with one way of solving this type of problems, that is via pattern matching and guard clauses. Consider a simple utility module that would tell us the type of input variable. So here we are defining a module utility, and within that utility we are defining two types. One is for checking binary value and the other one is for checking integer value. And these have the same signature and there can be other implementation. If the use of this module were confined to your own project, you would be able to keep defining new type functions for each new data type. However, this code could be problematic if it were shared as a dependency by multiple apps, because there would be no easy way to extend its functionality. This is where protocols can help us. Protocols allow us to extend the original behavior for as many data types as we need. That's because dispatching on a protocol is available to any data type that has implemented the protocol, and a protocol can be implemented by anyone at any time. Here's how we could write the same utility functionality as a protocol. So let's go to the console, enter the Elixir interactive mode, and let's define the protocol utility. Def protocol utility do, and we have the spec type t string dot t def type value end. Okay, we have defined the protocol utility. Now let's extend the utility protocol and define utility for bit string do def type underscore value do colon string end. Similarly, let's define an implication of utility for integer do def type value do colon integer and end that as well. Undefined function integer. Okay, basically we need it's within capital I. Def type value do integer. Okay, now we have utility, dot bit string, and we have utility dot integer. We define the protocol using def protocol. Its functions and specs may look similar to interfaces or abstract base classes in other languages. We can add as many implementations as we like using def impl keyword. The output is exactly the same as if we had a single module with multiple functions. So let's call utility dot type and let's pass in the string, and we get string because our implementation of string bit string is working and it's returning the string by checking the type of the value. Similarly, we can pass integer to our utility dot type function and we get integer. So as you can see, we are calling the same function, but we are sending different kind of data. We are sending strings, we are sending integer, but the protocol implementation is basically doing polymorphism, and it's giving us results depending on the input, and we are not defining the type when we are passing the value to the type function. With protocols, however, we are no longer stuck having to continuously modify the same module to support more and more data types. For example, we could get the def implement calls above and spread them over multiple files, and Elixir will dispatch the execution to the appropriate implementation based on the data type. Functions defined in a protocol may have more than one input, but the dispatching will always be based on the data type of the first input. One of the most common protocols you may encounter is the string.characters protocol, implementing its to_string function for your custom structs will tell the Elixir kernel how to represent them as strings. We will explore all built-in protocols later in this video. For now, let's implement our own. Let's implement a generic size protocol that all data structures for which size is pre-computed would implement. The protocol definition would look like this. So let's define the protocol. Def protocol. The name of the protocol is size, and dog type. This is the definition of the function, or you can say the description of the function. Calculate the size and not the length of a data structure. Define size, pass in the data, and end the protocol. So we have defined the size protocol. The size protocol expects a function called size that receives one argument, the data structure we want to know the size of, to be implemented. We can now implement this protocol for the data structures that would have a complaint implementation. So let's define the implementations for our size protocol. Def impl, that's for defining implementation, and we are going to define implementation for size protocol and for bit string. It's cap bit string. Do define size and string as a parameter. Do byte size string. So we will be returning byte size of the bit string. Similarly, we will implement it for maps. Def implementation size for map do, and def size map do map underscore size and map. That's our implementation for the map. And last is for the tuples. Tuple do def size tuple do colon tuple size and pass in the tuple. That's the end of our tuple function. We didn't implement the size protocol for lists as there is no size information pre-computed for lists, and the length of a list has to be computed. Now with the protocol defined and implementations in hand, we can start using it. So let's pass a string, let's say foo, to our protocol, and size.size. Okay, size.size and undefined function. Okay, we exited the interactive mode and then we came back. That's why it's giving us a problem. So we have to define the protocol again. So let's just copy it and copy and paste into the interactive mode. Okay, we have the size function now. Now let's create it for the string function, string implementation. Copy this and we have the string implementation, but okay, def size bit string size dot size food, and as you can see it returned us food. This is because of the bit string implementation of the size protocol. Now let's try the map implementation. Copy and clean it up here, and similarly the map one. Yeah, we need the map one also. So let's copy this here. Okay, so we have one for the map and then one for the tuple. Okay, we are done. Now let's pass. Okay, and hello, we got 2. That is the size of the map, and now we are going to get size of the map. Okay, size dot size percentage label and some label, and we get syntax error because we don't need to give this comma, we just need to pass in the colon and expected colon. Okay, there is no column prefix, so we get 1. Passing a data type that doesn't implement the protocol raises an error. So if we pass in list and there is no implementation defined for the list, we will get an error. So it says protocol size not implemented for of type list. Protocols and structs. The power of Elixir's extensibility comes with when protocols and structs are used together. In the previous video, we have learned that all the structs are maps. They do not share protocol implementations with maps. For example, math sets are implemented as structs. Let's try to use the size protocol with the map set. Size dot size, we get 0. Now let's set map set and sign it with map set dot new. Now if we pass in size dot set to our size function, we get protocol size not implemented error. Instead of sharing protocol implementation with map, structs require their own protocol implementations. Since a map set has its size pre-computed and accessible through map size.size, we can define a size implementation for it. So let's define a new implementation for our size protocol. map set do def size set do map set dot size set. That's the end of our implementation. If desired, you could come up with your own semantics for the size of your struct. Not only that, you could use structs to build more robust data types, like use and implement all relevant protocols such as enumerable and possibly size for this data type. So you can define a user module and then you can implement the size protocol for the user module. Now let's look at implementing any. Manually implementing protocols for all types can quickly become repetitive and tedious. In such cases, Elixir provides two options. We can explicitly drive the protocol implementation for our types or automatically implement the protocol for all types. In both cases, we need to implement the protocol for any. So for driving, Elixir allows us to drive a protocol implementation based on the any implementation. Let's first implement any as follows. So let's define an implementation size for any do, and the function size receives an underscore and do 0 and end. The implementation above is arguably not a reasonable one. For example, it makes no sense to say that the size of a PID or an integer is 0. However, should we be fine with the implementation for any, in order to use such implementation, we would need to tell our struct to explicitly drive the size protocol. So we can define another module, other user do, and we can derive the size protocol and the structure. When deriving, Elixir will implement the size protocol for other user based on the implementation provided for any. Fallback to any. Another alternative to derive is to explicitly tell the protocol to fall back to any when an implementation cannot be found. This can be achieved by setting fallback to any to true in the protocol definition. Let's look at built-in protocols in Elixir. Elixir ships with some built-in protocols. In previous videos, we have discussed the enum module, which provides many functions that work with any data structure that implements the enumerable protocol. So let's look at enum again and revisit it. 1, 2, 3. Function x multiplied by 2 and gives us an error. Syntax error before 2. Okay, enum.map comma fnx arrow function Okay, let's look at enum.reduce, and if we pass in the range 1 to 3 to enum reduce, and in the lambda function we are adding the function with its own values and we get 6. Another useful example is the string.cars protocol, which specifies how to convert a data structure to its human representation as a string. It's exposed via the to_string function. To string hello, and we get hello. Notice that the string interpolation in Elixir calls the toString function. So if we pass in double quotes age colon hash 25 double quotes, we get age colon 25. The snippet above only works because numbers implement the string.cars protocol. Passing a tuple, for example, will lead to an error. So if we define a tuple and we pass tuple to the above snippet, it gives us an error. String cars dot implemented for 1 2 3 of type tuple. When there is a need to print a more complex data structure, one can use the inspect function based on the inspect protocol. So let's try the same thing but add the inspect keyword just before tuple, and we get the data type and the value within the tuple. The inspect protocol is the protocol used to transform any data structure into a readable textual representation. This is what tools like IEX use to print results. So if we just pass in the tuple to IEX, we get the same thing as a output. Now let's check our user object. We haven't defined the user. This was in the previous video. Okay, that was all about Elixir protocols and how to use them in your apps. If you liked this video, don't forget to subscribe to my channel. If you need any professional help, you can email me at umehmood@gmail.com. You can visit my Facebook page or you can contact me via LinkedIn. I'll be more than happy to help you. See you next time with a new video in Elixir.